This is the first section of our Homework 2 tutorial. So in this section, we are going to talk about two problems related to using the formula here to calculate the coefficient. So for a normal regression function, yi equals to beta 1 plus beta 2 times xi plus ui, then we know that the formula of calculating beta 2 hat is this. And then in the formula, the little xi equals to xi minus x bar, the mean of x, and then yi equals to yi, little yi equals to yi minus y bar. And then now suppose we change xi to zi, which equals to the twice of xi. And then we know that z bar will equal to the twice of x bar, and little zi, which equals to zi minus z bar, consequently is 2 times little xi, the twice of little xi. And now if we run a regression of yi on zi and then apply the formula again to calculate alpha 2 hat, then we can see that alpha 2 hat equals to the summation of zi times yi over the summation of zi squared. And then we know that little zi equals to the twice of little xi, and then we substitute zi for xi into the formula, and then we can move the 2 and then the 4 out of the summation, and then we get alpha 2 hat equals to 1/2 of beta 2 hat, because this part is the formula here, and then it equals to beta 2 hat of the original regression. And so how about the intercept? We can use the formula of intercept to calculate alpha 1 hat, and then they will equal to y bar minus alpha 2 hat times z bar. And then we know that alpha 2 hat equals to 1/2 of beta 2 hat, and then z bar equals to twice of x bar. And then if we substitute both terms here for xi and beta 2 hat, x bar and beta 2 hat, then cancel out the 2's, we get alpha 1 hat equals to y bar minus beta 2 hat times x bar, which is exactly beta 1 hat. How about the residual? So we know the residual equals to yi minus yi hat, which is the predicted yi. And then the predicted yi equals to alpha 1 hat plus alpha 2 hat times zi. And then again, if we substitute alpha 2 hat with 1/2 of beta 2 hat and the zi with 2xi, then we get yi, the residual vi hat equals to yi minus beta 1 hat plus beta 2 hat times xi. And this is exactly the original residual. So what do we see here? We see that after we change xi to the twice of itself, the only change that happened is the coefficient on xi. And so the bottom line here is that the change of xi is absorbed only by the coefficient on xi. So the intercept didn't change, the residual didn't change, and then the only change is on the coefficient of xi, which says alpha 2 hat is 1/2 of the original coefficient. So in the second part, we see another change. Suppose we change xi to zi, which equals to xi plus 2. So we add a constant to the original xi. And then apparently z bar will equal to x bar plus 2. And little zi equals to zi minus z bar will equal to little xi, because the two 2's will cancel out each other. So if we run the regression of yi on zi, we can apply the formula here again, and then we will see that alpha 2 hat, which is the coefficient on the new regressor zi, will equal to beta 2 hat, which is the same coefficient on the regressor xi. And then we can apply the formulas again to calculate the residual and the fitted value. And you will not see any change on them. So if you don't want to use all the formulas to make the calculation, there is an informal way to kind of make sense of what is happening here. So what can we do? We can just compare the two regression functions. So if we look at these two regression functions, yi equals to beta 1 hat plus beta 2 hat times xi plus ui hat, the residual, and then yi equals to alpha 1 hat plus alpha 2 hat times zi plus vi hat, the residual. And then we know that zi equals to xi plus 2. And then we put xi plus 2 here, and then we arrange the terms. We will see that the constant part of the regression function is alpha 1 hat plus 2 times alpha 2 hat. And then the coefficient on xi is alpha 2 hat. And the residual is vi hat. If we compare the first line and then the last line, you will see that because we have data on yi and xi, we will only get one estimated coefficient. So beta 1 hat will be equivalent to this term here, and then beta 2 hat will be equivalent to alpha 2 hat. So that's why we see here in the calculation we get alpha 2 hat equals to beta 2 hat, because they are equivalent terms if you compare these two regression functions. And again, so just answer the question we posed a moment ago. So what will be the change of the intercept? So the intercept alpha 1 hat will equal to beta 1 hat, the original intercept, minus this part. So that's the answer for this question. So in 3.16, we can also use the formula in a smart way to solve the problem. So for regression function yi equals beta 1 plus beta 2 times xi plus ui, we have the fitted yi here. And then suppose we run the regression of yi on the fitted value y hat. What will be the new coefficient alpha 1 hat and alpha 2 hat? So to apply the formula here, we need to know what is little xi. Little xi will in this way become little yi hat, which equals to yi hat minus yi hat bar. And then what is yi hat? Y hat equals to beta 1 hat plus beta 2 hat times x, which is the fitted value of yi. We get it from here. And then how about y hat bar? Y hat bar is actually the mean of this term. And then the mean of this term equals to beta 1 hat. This doesn't change because it is constant, plus beta 2 hat times x bar. So the only thing that we take mean of is x, and then x becomes x bar. And then if we cancel out the beta 1 hats, we get little yi hat equals to beta 2 hat times the difference between xi and x bar, and then it equals to beta 2 hat times little xi. And then, so now we can use the formula to calculate alpha 2 hat. So we know that little yi hat equals to beta 2 hat times xi, and then we put that into the summation and then move beta 2 hat out of the summation terms because beta 2 hat is a constant. Then we actually see that alpha 2 hat equals to 1. And then how about the intercept? The intercept alpha 1 hat equals to 1 y bar minus alpha 2 hat times y hat bar from this regression. And we know that alpha 2 hat equals to 1 from last step. And y hat bar equals to beta 1 hat plus beta 2 hat times x bar from this step. And then we know that because the regression function, the original regression function passes through the mean, meaning that y bar equals to beta 1 hat plus beta 2 hat times x bar, we can see that this term equals to 0 exactly because they cancel out each other. So that's why we will see this question is a true statement because the coefficient on the regressor will be 1 and then the intercept will be 0. That's the end of this section. If you have any questions or comments, please leave them under the video and then I will reply them, or you can reply to each other in a timely manner. Thanks.